Pre-Calculus, Lesson 1.9, Distance and Midpoint Formulas, and Circles. This unit we've really been focusing on functions and their graphs. In this case, though, we also want to make sure that we touch on another very important graph, in this case, the circle. But before we get to that, we need to review a couple of concepts from geometry. The first one that we're going to talk about is the distance formula. The distance d between the points x1, y1, and x2, y2 in the rectangular coordinate system can be found by using the formula big square root of the difference of the x's squared plus in the differences of the y squared. In this case, what we're going to do here is always take the principal square root of the sum as the distance. So for example, if we wanted to go ahead and find the distance between the 2 points, -1, -3, and 2, 3. In this case, I'm going to go ahead and label our points x1, y1, and x2, y2. But please note that it does not matter which point you use first. As long as if you start using one point, then you need to make sure you use that x and y coordinate first in both your differences in the formula. So for example, if we're going to set up this formula, we're going to take the differences in the x's, or 2 minus -1 squared, plus the difference in the y's, 3 minus -3 squared. And if I go ahead and simplify that, we'll get 2 plus 1, which is 3, and then 3 plus 3, which is 6. From there, using the order of operations, we're going to make sure that we square both of those, giving us 9 and 36. Then we're going to add those together to get square root of 45. Notice here that we're told to write our answers in simplified radical form and then also round to 2 decimal places. So we need to remember how to break down our roots using perfect squares. In this case, we can note that 9 times 5 equals 45, so we can break that down into 3 square root 5. And if we go ahead and type that into our calculator and round to 2 decimal places, we will get that this is approximately 6.71. So the distance between the 2 points is about 6.71 units. Let's try this again. In this case, consider we want to take the 2 points, 2, 3, and 14, 8. If we go ahead and set up our distance formula, in this case, I use 3 first, and so I'm going to do 3 minus 14 squared for my x values. Oop, actually I made a mistake there. Should be 2 minus 14 as my x value, and then my y values of 3 and 8. So if I go and subtract there, 2 minus 14 gives us -12 squared, and then 3 minus 8 gives us -5 squared. Notice how I put the negatives in the parentheses so that we remember when we square to get positives. This will give us 144 and 25. If we go ahead and add this together, we get square root of 169, which comes out perfectly to be 13. So 13 would be our answer in both simplified radical form and decimal form. The next formula that we need to talk about here is the midpoint formula. If we consider a line segment whose endpoints are the coordinates x1, y1, and x2, y2, then the coordinates of the segment's midpoints are going to be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. This is the same thing as taking the average of the x-coordinates and also the average of the y-coordinates. Notice this is going to be a point that we're getting as a solution, not a number, so this is a point. So for example, consider that we want to find the midpoint of the line segment with endpoints at 1, 2, and 7, -3. To find the midpoint, we're going to start by adding the two x's together, giving us 1 plus 7. And then we're also going to add the y's together, giving us 2 and -3. If we go ahead and add the numerators and divide by 2, we'll get 8 over 2 and -1 over 2. If we reduce, this means we'll get the midpoint of 4, -1/2. These right here is the coordinates of the midpoint, or in this case, another thinking of as the point that is directly in between the 2 points on this segment. Our next example is finding the midpoint of the 2 points 8, 3 square root 5 and -6, 7 square root 5. We're going to use our midpoint formula just like we did before. averaging out the x's and averaging out the y's. Notice here if we go ahead and add for our x coordinates, 8 plus negative 6 divided by 2, that will give us 2 over 2. And then for our y coordinates, if we take 3 square root 5 plus 7 square root 5, we get a total of 10 square root 5. From here then we're going to reduce. In our x coordinates, notice that the 2's are going to cancel out, leaving us with just 1. And then in our y coordinate, we can go ahead and divide that 10 by 2, which is going to reduce to a 5. And so, the coordinates of the midpoint for this segment is going to be 1, 5 square root 5. When working in the coordinate plane, the distance and midpoint formulas can help us find the equations of circles. So it's important for us to define what a circle is before we go further. Note, a circle is going to be the set of all points in a plane that are equidistant from a fixed point, called the center. The fixed distance from the center circle to any point on the circle is going to be called the radius. We will always denote the center of a circle using the coordinates hk, and the radius will be denoted as r. Any other point on the circle we will use the coordinates x, y. The standard form of the equation of a circle is given below. In this case, using the coordinates of the center hk and the radius r, we get the standard equation to be x minus h squared plus y minus k squared equal to r squared. Say, for example, we want to write the standard form of the equation of a circle with a center at 0, minus 6 and has a radius of 10. Well, in this case, that center is going to be our h and our k, so we can write this as x minus 0 squared plus y minus a negative 6 squared equal to 10 squared. And so if we simplify this, we'll get the standard form of the equation of the circle to be x squared plus y plus 6 squared equal to 100. It is always important for us to simplify our equations as much as possible. Let's say we're going the other way and want to pick out the information given the equation. So, first of all, we want to find the center and the radius. Well, in our equation, we know that the center is going to have coordinates hk, which is given in the set of parentheses on our equation. The important thing to remember here, though, that in the standard form of the equation it is always x minus h and y minus k. So we have to take the opposite of the coordinates that are found in our equation. So the center here is going to be at -3, +1. Then to find the radius, since in the standard form of the equation of the circle, we're always equal to r squared, and if r squared is equal to 4, we can go ahead and square root both sides, making that our radius for this circle is going to be 2. So suppose now that we want to actually graph this equation, or graph this circle. So we're always going to start with the center. Since we had the center at -3, 1, +1, we're going to go ahead and graph that point first. And then from there, we can go out in all 4 coordinate directions of 2 with our radius and then connect our points. It doesn't have to be a perfect circle, but try your best. Beyond the standard form of the circle, we also need to talk about the general form of the equation of the circle. The general form is given as x squared plus y squared plus dx plus ey plus f equal to 0, where d, e, and f are going to be all real numbers. Finding the general form of a circle, or finding the general form of the circle's equation given for the standard, in this case, means that we're going to have to be using completing the square. We will review this process in this example. Our first step, what we want to do, is always go ahead and get that constant term by itself on the other side. So in this case, we're going from general to standard. So this will give us x squared plus y squared plus 8x plus 4y equal to a -16. The next thing we want to be able to do then, from here, is go ahead and group our x terms together. So we're going to get x squared plus 8x. I'm going to leave a little bit of room and explain why here in a sec. Then also group our y terms together, giving us y squared plus 4y, also leaving a little bit of room, equal to negative 16. Now from here, if you see that I left a little bit of room, and we can just look at the part that we have x squared plus 8x, you'll notice this kind of looks a little bit like a trinomial. And this is where we're going to be completing the square. To complete the square, what we're going to do is take the middle term, and then we're going to divide it by 2 every time. So in this case, 8 divided by 2 will give us 4. From there, then, what we're going to do is square it, giving us, in this case, 16. So we're going to put 16 in our spot, which will give us the trinomial x squared plus 8x plus 16. Recall, though, if we add one thing to one side of the equation, we have to add to the other as well. And so that will give us, we're going to add 16 to the right side as well. And then we're going to do the exact same thing with the y's. So we're going to divide the middle term by 2 and then square, giving us 4. So we're going to add 4 to the left side, but also to the right. If we look at the trinomials on the left-hand side here, we might see that they are kind of special patterns that we've used before with our factoring. So just recall here that if we have a trinomial in the form a squared plus 2ab plus b squared, that's going to be equal to the factors a plus b squared. Similarly, if we take a squared minus 2ab plus b squared, that will give us the factors a minus b. These are our perfect square trinomials, and we're going to use these to reduce these trinomials into the factored form. Another way of thinking about it is if we're trying to use our trinomial factoring, we would need two numbers that multiply to 16 and add to 8. But in this case, that would just be x plus 4 and x plus 4. So we can write that as x plus 4 squared. Similarly, if we're trying to think of two numbers that will multiply to 4 and add to 4, well, that will be positive 2 and positive 2, and giving us, in this case, x plus 2 squared. We also note here then that if we simplify the right-hand side, the positive 16 and the negative 16 cancel out, leaving us with 4. This will give us our final equation of x plus 4 squared plus, that should be a y plus 2 squared equal to 4. So for this circle then, we will have a center of the opposite at negative 4, negative 2, and then our radius here will be the square root of 4, in this case also 2. Let's try this again with another example. Consider the equation, the general form of the equation, and let's go to standard. So we're going to go ahead and add over the constant term first, giving us x squared plus y squared plus 12x minus 6y equal to a positive 4. From here then we want to group our x terms together, leave a little bit of space for our completing the square, and we're going to group our y terms together. Again, leaving a little bit of room to complete the square. And from here then we want to go ahead and complete the square. Divide the middle term by 2, which gives us 6, and then we're going to square, giving us 36. Then we're going to add that to both sides of the equation. Similarly, we're going to do the same thing with the y. Divide the negative 6 by 2, giving us negative 3. And if we square that, that's going to be in parentheses, so it's going to give us a positive 9. And so we're going to add 9 to both sides. So once we do that, then we can go ahead and collapse those trinomials. And the first one with the x's, we are going to need two numbers that multiply to 36 but add to 12. Well, this will be x plus 6 and x plus 6. Similarly with the y's, we're going to need two numbers that multiply to a positive 9 and add to a negative 6. Well, in this case, that would be negative 3 and negative 3. So we can collapse this down to y minus 3 squared. And if we go ahead and add and combine like terms all on the right, we're going to get 49 out, giving us this standard form of the equation of the circle. X plus 6 squared plus y minus 3 squared equal to 49. If we look at that equation there, then we can decipher that our circle will have a center at negative 6, positive 3, and then a radius of 7 if we take the square root of 49. This right here is going to be how we're going to go between the general and standard form of the equations of a circle. Please pause here and go back to any of these examples if you feel like you need more time.